Okay, lesson 6.2, properties of exponents. This one is pretty fully loaded, as you can see by the key ideas. So I'm going to talk about a few things here, and then we're going to move on. I'm also going to be giving you a sheet that will kind of summarize a lot of these. So the product of powers property. The main thing here is that we have the same base, and then you will add exponents, okay? So, base is 4, you have the exponents of 6 and 3. So if you're multiplying those together, it's kind of like we have 6 factors of 4, and then 3 factors of 4. So how many factors of 4 altogether? Well, 6 plus 3, we have 9 factors of 4, okay? So this is the general guidelines that we're going to use. When it's the quotient and we're dividing, we have the same base. We want to subtract their exponents. Again, in the numerator, we have 6 factors of 4. In the denominator, we have 3 factors of 4. So we've learned to simplify, right? We could probably cancel off 3 of those factors. So we're subtracting the exponents, and we are left with 4 to the third power. When we're taking a power of a power, we have an exponent, right? And then we are taking that to an exponent. This is when we can multiply the exponents. So notice the difference between power of a power and a product of powers. One we add, one we multiply. Very big deal. So we're taking something that has an exponent, then we're raising it to an exponent. So it gets exponentially large. All right, so then we have the power of a product. So inside, now this is kind of a silly thing to show, like 2 times 3, because why wouldn't we just have that as 6? It becomes more relevant when we have variables involved, or like, 2 x to the 5th power, right? Because then we're like distributing this to both. So we would have 2 to the 5th and x to the 5th, so to speak, and then we can evaluate and so forth. The same thing is true when you have the quotient property. This is not so bad because you know that you have the fraction. You have to take the 5 as an exponent of the 3 and the 5 as an exponent of the 2. Same with the variables and so forth. One thing that I want to bring into and remember or remind you of is the 0 exponent property. And if you can recall, a to the 0 equals 1. Why is that? Because if we took a squared over a squared, right? We learned it in the quotient rule, so we're kind of borrowing it from down here. We would say that's equal to 2 minus 2, which is equal to a to the 0 power, but technically it's equal to 1. Can you see this fancy form of 1 that we have here? My drawing is not so great, but that's like a, fraction equal to 1. Now, I must also add that 0 to the power of 0 is undefined. And because of this example that I used, in order to get this, right, we would be taking that 0 is the base. We would be trying to divide by 0. Dividing by 0 is undefined. Okay, moving on, we have another property, and that is the negative exponent property. Okay, so if you have a to the negative n, that is equal to 1 over a to the positive n. You're going to take the reciprocal of the base, and give it a positive. So we always think of exponents, right, as a repeated multiplication. So this 2 to the 5th is telling us how many times 2 is a factor. 2 times 2 times 2 times 2 times 2. All right. If it were negative, if that were a negative 5, it would be like a repeated division. 1 over 2 divided by 2 divided by 2 divided by 2, so forth. So kind of try to understand how this negative exponent works, relate it in terms of the 0 exponent. If we need to talk about it more in class, we will, but I'm trying to limit the length of my videos, so I'm not going to go into all the talk that I used to do, but I can have a lot more explanation on this. But as you even notice, it's not even included in this. It's supposed to be prior knowledge. So we will be doing a lot more practice with this, but you might need some further explanation, and I will be glad to give it to you. So go ahead if you need to copy any of this down, or if you're already good to go. I'm going to go ahead and clear. All right, so in the examples, it says simplify, and the big key here is we're always going to be given our answers with positive exponents. If we ever get a negative exponent, we want to simplify that. So the base is the same, add the exponents. Notice the base is the same, and notice this is -4 is the base, and there's parentheses around that negative. That's how we know that the base is a negative, and we'll see in a future example when that's not the case and the difference between the two. So we can take our -4 base, 2 minus 7, we get the -5. Then we want to do the definition of negative exponent, take the reciprocal of this, right? This is over 1, so we're going to take 1 over this -4 and put it to the 5th power. Okay. Here, the base is z, and we haven't done much with the variables yet, but here's z to the 4th power. Now we have the power of a power property, so we are going to multiply 4 times -3, z to the -12th. We have to give a positive exponent, so 1 over z to the +12. All right, so let's do some of these. Let's see, pick and choose which ones we're going to do. Maybe we'll do them all. I don't know. Gosh darn. Okay. All right, so here we go. In the first one, base of 10. So we are going to add the exponents. 4 plus -6. It's going to give us 10 to the -2. So we would write it as 1 over 10 squared. Okay, to give a positive exponent because it said only positive exponents. Here we have the base of x. So we're adding the exponents, 9 plus the -9. So that gives us 0, which is equal to 1. Okay? Here, this is where I was talking about. This is different. This is different. Number 3 is not this. Notice the difference here. Okay? So here the base is -5, and in number 3 the base is 5. Okay? So there's a big difference here. So what we really have is like -1 times 5 to the 8th over -1 times 5 to the 4th. And you may not be able to understand that or see that, but there's no parentheses protecting that negative sign to say that that's part of the base. So the exponent only applies to the number, and then this just means the opposite of, or it's like times this -1. In this case, we could cancel here. We could cancel this because we'd simplify that. Then we would do the 5, 8 minus 4. And so our simplified answer would be 5 to the 4th power. Okay, 5 to the 4th power. And there's no negative anything. Okay, on to this one. Well, we would take, it's division. So we're going to subtract. We're going to take, we have 6 y's in the numerator, and we're going to subtract 7 of them. But obviously, we're going to run out of space because we're going to say y, and we take the numerator minus the denominator. So we're going to get y to the -1. So that's going to be equal to 1 over y. Okay, product power of products, we're going to multiply these. So -2 times -5, 6 to the +10. And here, 12 times 5 is w to the power of 60. So using all the different powers, and I will be giving you a paper that'll kind of summarize these. It will help greatly for when you're working on them in class. You can kind of use it as a addition to your notes. So I'm getting ready to clear. All right. Now we're going to add a lot more variables and fun. Here we go. So write your answers using only positive. So here, this is the one where we want to, it's going to apply to both. Notice that you get the exponent to the -1.5 and to the y, and then you evaluate it. Here, the 3 goes to the a and to the -10, and then the whole thing is negative, and since we're going to take the 10 cubed, we're going to make that 1,000. Here, When you apply this, you're going to get, because it's negative. Now look what happens here. We already know that this is negative, so we're going to take the reciprocal of this base right here. That's right here, 3 over 2x. 3 over 2x is the reciprocal of 2x over 3. And then we can apply the positive exponents. Okay, that is how we deal with or define these negative exponents. Then we can take and do the 3 to the 5th, and then this is like distributing to both of those, 2 to the 5th, x to the 5th, kind of like that example I did with the key idea. Evaluate, in this case, to simplify. 2 to the 5th is 32. If there were anything that could simplify between 243 and 32, you would want to do that, and there's not. All right. So we will do a few of our own. And here we go. So using only positive exponents. So we want to distribute. So 10 to the negative 3, y to the negative 3. So that's going to be, we have to take the reciprocal of both of these. So it's going to be 1 over 10 cubed y cubed. And then we'll evaluate the 10 cubed. 1 over, and it's a 1 with 3 zeros, y cubed. Okay. Here, the exponent of 5 goes to the numerator and the denominator. It's positive, so we'll have this 4 to the 5th over n to the 5th. And when we evaluate 4 to the 5th, we get 1,024. You can do that on your calculator, and I'll show you how to use the exponent key if you don't know how. Since we don't know what the variable is, we just leave it like that. Okay. Again, here it's going to apply here, and it's going to apply to everything down here. Okay. So we have 1 to the 5th power, and then we have 2k squared to the 5th power. So 1 is the numerator, because any 1 to any power. And then we have 2 to the 5th power, and then k to the 10th power, because this is like the power of a power. So 2 times 5 is 10. And then we can evaluate the 2 to the 5th. So 2 to the 5th is 32, and that's k to the 10th. Okay. This is negative, so that means we're going to do this 6c negative 2 over 7 negative 2. So we kind of want the reciprocal right here of this fraction. Take the reciprocal of that so that we can make these positive. So we'll have 7 squared over 6c squared. So 49 over 6 squared c squared, or 49 over 36c squared, and then check to see if there's anything between 49 and 36 that can be simplified. And we have only positive exponents. Okay. I know that was a lot. I'm going really fast. Sorry. Clearing. So let's go ahead and do one more. Okay, it takes the sun about 2.3 times 10 to the 8th. So we're getting into scientific notation. Quick refresher on scientific notation. This is in the form of c times 10 to the n. C is this decimal number that is greater than 1 and less than 10. So you always want to make sure that it's a decimal greater than 1 but less than 10. So 1 is less than c, which is less than 10. 9.999, whatever it is, depending. The significant figures will vary depending on what you're applying it to, but you don't want it to be less than 1. It could be 1 point something, but it won't be less than 1. N is an integer. Okay? If n is positive, we're talking about a large quantity, like greater than 1, right? Greater than 0. And usually scientific notation is what is used so that, like, 10 to the 8th, that's 8 zeros. So we're talking about things that are like in the, this is 100 million level numbers, and it allows scientists to not make mistakes by having to put in all those zeros. Okay, so it's a way to use like a mathematical shortcut in a way, and still give meaning and value to the number. Okay, so these are both positive exponents. So we're talking about, larger quantities. If it is a negative number, a negative integer, or n is negative, okay, we're talking about being a small value. So now we're talking about it being in like the tenths, hundredths, thousandths, millionths. Think of that. And the number itself would have had like a decimal and then a bunch of numbers after it, and be very, very tiny, like microscopic kind of a thing. So all right. So this is magnitude. This helps us determine the magnitude. All right. So now we're talking about how many years it takes to orbit the center of the Milky Way. So then we're talking about the sun, 2.3 times 10 to the 8th years. It takes Pluto, which is no longer a planet, about 2.5 times 10, squared. This is like hundreds, right? Years to orbit the sun. How many times does Pluto orbit the sun while the sun completes one orbit around the Milky Way? Okay, so how many times, what number times this would equal this? So that's what you're going to start doing. You're going to write 2.5 times 10 squared, right? And as you can see, I just descended into darkness, so the sun is no longer out. We have 2.5 times 10 squared times some number x is equal to our 2.3 times 10 to the 8th. So this is where those property of exponents is going to come into play, because to solve for x, we have to undo multiplication. So we're dividing both sides by the 2.5 times 10 squared. Okay, now, not sure if you remember doing this, but we're going to do this in sections. Okay, so we'll do the decimals first. We want to take and do 2.3 divided by 2.5. And then we have our bases are the same, so we can use our property of exponents to subtract the exponents, right? The quotient property allows us to subtract them. So if you did this on your calculator, you would get a number that is less than 1.92, right? Because that's smaller number on top. Now, we know that this first part of it has to be greater than 1. So I am going to have to move this decimal to the right one place. Okay, I'm getting ahead of myself. Let me finish writing this. So 0.92 times and then 10 to the 6. And since I am moving it one place to the right, and it started out as a small quantity, that means I am subtracting 1 from here so that I get 9.2 times 10 to the 5th times is how many times Pluto orbits the sun while the sun is completing its orbit around the Milky Way. And we're writing our number in scientific notation. Okay. So if you are doing any kind of scientific notation, practice with multiplication, and you have to multiply the numbers together. You want to multiply the two decimals together, then multiply the powers of 10 together and use that property rule, and then simplify it this way. Again, if you're going from 0.92, it's a smaller quantity, right? So that was a negative exponent, was that negative 1. That's how I got that negative 1, because I moved it one place. If the number was like, say, what if it was the other way around and it was larger, right? And we get a number, and not in this example, but, well, what if it was this example? 2.5 divided by 2.3. Well, if we did it the other way, we would have gotten a number that would have worked in the right form. So we don't have to worry about that. But sometimes you get numbers like 12 or 15 or something like that, and you're going to move the decimal the other way, well, then you're going to add to that because it's a positive, larger quantity. Okay, so I'm going to clear this. Get ready. Here we go. And you are ready for the vocabulary and concept check. Make sure that you're identifying which one you are answering. And look, you have 5 choices. So select one of these. You're only selecting one of these. But looks like 1 through 4 is matching. So if you're choosing 1 through 4, if you're doing the matching, you'll need to put the matches together, like 1A, 2B, 3C, 4D. And obviously that's probably not the case, but go ahead and, put the letters and numbers together as which ones are matching. And then number 5, if you choose that one instead, different words, same question, which is different, find both answers, meaning simplify it and simplify all of them and see which one is different and then find both answers. The ones that are the same and then the one that's different. So basically you're simplifying all 4 things. All right. Opportunities don't happen, you create them. And have a good night. And if you have any questions, make sure that you let me know. I'll see you in class.